Alright, now that you know how to load data in Python via Pandas, and you know how to do that using different data sources, as you saw CSV, JSON, text files, and Excel, and now you want to understand how and learn how to manipulate these data frames. And by manipulation, what I mean is deleting rows and columns from your data frame and adding new rows and columns, and also modifying existing rows and columns. So that's what you're going to learn throughout these lectures. But first of all, I'd like you to understand how data frames are indexed. And with indexing, I mean, we have this data frame here, and this can be a big one. So this happens to be a shorter one with only 6 rows. But if you have big data frames with lots of columns and rows, then you may want to extract information out of that data frame. And to extract information, you need to have like a coordinate system in that data frame, like an embedded coordinate system. So that if you want to access, let's say, from here and 15 to, and then maybe this other portion, so these 2 rows here, this portion in here, you want to know how to do that. So that's what you're going to learn now, how data frames are indexed and how you can slice them. So let's try to extract that portion of the data frame. Let me create some empty lines here. I don't want to confuse you with that data frame, so we're working on this one. And yeah, df7. And what you want to apply now, there might be different ways to access that portion of the data frame. The first way is to use label-based indexing. The other way is to use position-based indexing. So your data frame has column labels and index labels. So these 1, 0, 1, 2, 3, 4, 5 are index labels, and these are column labels. Now these, the index label, in our case, it's a bit confusing because normally it can be text, such as, let's say, in our data frame, the address is a unique column which you can use as an identifier. So if you want, you can set that as an index. Address, execute, and now you see that this is in bold. So the first column is in bold, meaning that this is the index column of your data frame. So now you can use labels from your index column and labels from your header, your column names, to access portions of your data frame. Just be careful though, because with this operation that we just did here, if you print df7 now, df7, you'll see that you still have the old index column in there, so 0, 1, 2, 3, 5. The reason to that is this set index method, as many other methods in Pandas, is not an in-place operator. Meaning that all this will do, it will spit out an updated data frame, but it will not store that data frame in your variable. So the variable, the data frame, remains the same. It just prints out a new data frame on the fly, just for printing purposes. So what you want to do to store that is you create a variable, which can be the same variable as this, if you just want to update your variable. But it can also be another variable like df8. I'll just want to update the existing variable. Like that. And that will not print out any output. So you want to do that manually, like this. So now when you print df7, you see that df7 is updated with this address column as an index of the data frame. So be careful with in-place operations. You can see that df.set index, a question mark to ask for help. Oh, sorry, it should be df7 set index, and you can see that you have this in place parameter there that is set to false by default. So which means you can also pass in place after this and set it to true, and that will update the existing data frame without the need to save the data frame to a new variable. But I would recommend that just get used to creating new variables when you apply methods to your existing variables, existing data frames, and it should be good to go. delete that, and yeah, let's get back to our original purpose now, which was to slice this portion of the data frame. And we'll first do it using label indexing. With label indexing, you want to use a loc in there, so the loc method. And then you pass square brackets in there, and then that gets two elements. And the first element could be a range of the index column. So we're talking about labels, about strings, so you'll have to pass, 735 Dolores st, and then a range, so with a column there, 332 heal st, and then from country to id. Execute that, and yeah, this is our portion. So when you use labels, you're including the first label that you pass there and the last one as well. So everything between those. And like here, country and employees is included as well, but ID also. And of course, almost similarly, you can access, single cells from your data frame, just like that. So the intersection between this index label and this column name is USA, which should be this one here. If you want all the USAs, then you just pass everything there and you get everything here. Which of course, if you want, you can convert it to a list. So a simple list using the Python built-in function, which is list. And that's about label-based indexing. Now, this is not the common way to extract data from the data frame. More common could be to access data based on indexing, not based on labels. So to do that, you do df7, and instead of loc, you do iloc. That again expects two items. So the first would be the range of your indexes. Actually, let me print out the data frame here so that you can refer to that. So let me access from Dolores to 23rd Street. That would be 1, 2, 3, I believe, yeah. And also from country to ID. So again, 1, 2, 3. And yeah, you can see the difference now. The ID wasn't included there, and either was 23rd Street, because this is, as you do with list, this is upper bound exclusive. So with Python list, 3 is not included in the slice. But with labels, the last item of the range was included in the slice. So in this case, you want to pass 4 there and 4 there, and that's how you get your portion. And of course, similarly, you can do things like that. So you get all the rows or only one of them. So that would be a row with index 3, which is this one, but only 4 columns: country, employees, and ID. So USA 10 and 4. All right. That is position-based indexing. Now we have one more very useful kind of indexing, and that is combined indexing. So in certain scenarios, you might need to access a portion of rows without having to pass names for the rows. So you want to access rows based on indexing, based on their position. But on the other hand, you don't want to access columns based on positions. You want to access like a certain column, so which name you know about. So you don't want to count the column. And here comes in handy the ix method. So that allows you to enter a combination of indexes and labels. So that will return you the row with index 3 and the column with the label name. So you get Ben's shop. And you cannot do this neither with iloc nor with loc. That's why ix exists there. And of course you can put 2 positions if you like. So name would be 0, 1, 2, 3, 4, you get the same output, Ben's shop. Which brings us to the point that if you want, you can always use IX and forget about iloc and loc. But IX is not recommended over iloc and loc. So these are more explicit, and they will avoid errors sometimes when you do position-based indexing. So I also suggest you use iloc and loc whenever you can, and then switch to IX when you want to do these kinds of combinations between labels and positions. And yeah, that's what I wanted to teach you about DataFrame indexing and slicing. And I'll talk to you in the next lecture, where you'll be learning how to delete columns and rows from a DataFrame. See you there.